Welcome our dear candidates to this science lesson. I'm very sure you're going to enjoy this lesson and you're going to really see how we can apply this machine you've been discussing about. Like yesterday, we discussed about the classes of levers, the first class lever, the second class lever, and the third class lever. But more importantly, we want to be more specific in this case. We want really to drill to get more about this one example of the first class lever. What is that? That is the seesaw. And this seesaw, there is a law which we are going to apply so that you can really get the points very well. Okay? And what is that? That is what we call the law of moments or the principle of levers. Okay? But we need to get to know more about that. Okay, so I think there. So we have to say the principles of moments or the law of moments. So this law of moments, in this discussion, we are going to see how we can really, more specifically, apply this law of moments on one of the examples of that machine which falls in the first class levers, which is the seesaw. But what is a moment? A moment is a turning force of a machine. For example, since you have said on levers, look at this. If this is my seesaw, which you always play with there, nursery section, or at home, it is even there, or even if you got the Freedom City, it is there. So when you sit, or when you apply the load, just here, you apply the load. For example, I can say, in this case, my load is the rubber, or this sharpener here. And this side, I apply the effort so that I can balance it very well. Now, meaning where the effort is set, there is a distance between the effort and the pivot, and where the load is, there is a distance between the load and the, I think the distance between the load and the pivot. This distance is what we call the load arm. And the distance between the effort and the pivot is what we call the effort arm. So in this discussion of ours, when you are applying this law of moments, we are going to talk about load arm, effort arm. Okay? Good. Now, what is the principle of moments or the law of levers? Or we can say the law of moments. This is what it states. It says that the load force multiplied by the effort force, the load force multiplied by the load arm is equal to the effort force multiplied by the effort arm. What do I mean in this case? This is what I'm meaning. That if this is the load here, this is the load, and there is a distance between the load and the pivot. When I get this distance, which I'm calling the load arm, times the load, it must always be equal to the effort, which is here, times the effort distance, which is the distance between the effort and the pivot. That's what is there as a law. This law, you can also simplify it. When, in summary, you can also say that the clockwise moments are always equal to the anti-clockwise moments. These are not two laws or principles. It is one law, but I've tried to simplify in the second one. You can say the clockwise moments are always equal to the anti-clockwise moments. Meaning, what you have multiplied on the side of clockwise, that load times the load arm, is always equal to the effort times the effort arm, or the other side of the anti-clockwise moments. Okay, so in summary, we can use letters, words here, say load times the load arm equals the effort times effort arm. But since we are going to deal with calculations, we need to avoid these words and use letters. For example, we can say load is L, load arm is LA, capital letters, equals to effort times effort arm, which is EA. All these letters in capital letters. So in summary, that is the law of moments or the principle of moments. or the principle of levers. That is it. So it is our formula which we are going to be using. For example, I sat on this side and Madame Lucy is on this side, what do we need to do to balance? That's what you're going to catch it here, okay? Okay, the distance of Madame Lucy and mine must be worked on and we balance very well. Thank you very much. Now, okay. So what the question is there? What does the principle of moment state? So if they ask a question like that, please pick one of those two. One of those two. Do you want the first one or the second one, which is the summary? The clockwise moment are always equal to anti-clockwise moment. Or if you have nice vocabularies like mine, then what do you say? The load force multiplied by the load arm is equal to the effort force multiplied by the effort arm. Okay, good. So where can we apply this? We want to see the examples here involving calculations where we can apply this law of moments. Okay? For example, when we are going to calculate, there are some things we need to note. One of them is this. We need to take note of the principle, the law of moments. Please, before you make any calculation, the principle or the law of moments must be here. You must know that law to work it out. Knowing that the clockwise moments are always equal to anti-clockwise moment. What you have multiplied this side on the clockwise moment must always be equal to what you have multiplied on the side of the anti-clockwise moments. Okay, look at my example. A man weighs 60 kilogram force. He sits 1.5 meters from the fulcrum of a seesaw. How far from the fulcrum will the boy whose weight is 30 kilogram force sit in order to balance with the man? Passing that number needs you to really apply the law. And then the other thing, we need to borrow some knowledge from mathematics. Before we calculate this, we need to sketch that question in a diagram form. So look, we need to sketch it just like that. That yes, this boy is there and he has 30 kilogram force. The distance of that boy from the pivot is just x, right? And there is a man on the other side, on the anti-clockwise side, who is just 60 kilogram force. And this man is at a distance of 1.5 meters. They want us to find how far is that boy from the fulcrum. Want us to find the value of that x which we don't know. Okay, remember we said, sketch the diagram if you want to pass it. Simplify, just like in mathematics and geometry. We first sketch a diagram. 2, apply the law of moments, which says that the clockwise moment are always equal to anti-clockwise moment. Calculate. Multiply on this side must equal what you have multiplied on the other side. Okay. Okay. So we need to be mindful of the position of the load arm, and the fulcrum, and the effort arm as we calculate. For example, let that man that question be the effort. Okay. In that question, let that man be the effort. And the boy is going to be what? The load. Okay? So remember, if that is the load arm is going to be our x, which we put in our diagram as x meters, we represent very well. And now the law comes in a formula way. That load times load arm equals to effort times effort arm. The distance of the load, who is the man in that case, must be multiplied by the load arm, must be equal to effort times the effort arm. Don't worry, candidates, don't worry. If nobody will ever tell this is the load, this is the effort. So please name any of the two what you want, as long as you get the value, what you have asked to find. So now we go, that's 30 kilogram force times the x meters equals to 60 kilogram force times 1.5 meters. Now candidates, in order not to get confused, we need to ignore the letters. Ignore the units, that kilogram force, remove them. Deal with figures now and letters. For example, say 30 times x equals to 60 times 1.5. But this 1.5 is in decimal. So you need to change it into an improper fraction, which is 15 out of what? 10. So we reduce it and say 30 times x equals 60 times 15 out of 10. So this 0 goes by the 0. Okay, what do we have there then? Good. So now we have 30 times x equals to 6 times 15 divided by 30. Why are we dividing by 30? In order to remove the 30 on this side, we need to divide on both sides and remain with x. So our x, that 30, goes by 30. We have now there 1. This side you have 30 by what? Okay, that is now 6 by that. We have this 5. Okay, then we have, that's 1. So we have our x equals to 1 times 15. Okay, remember we have that 5 there, so that this is 5. That is 5 by 5. It is 1 by 5. It is 1. Then by 15 by 5 we get 3. So we have remained with 1 times 3, which is our x at 3 meters. Thank you, thank you, thank you. Who has got that one very well? Good. How I wish you can call me. No, don't call me and tell me that you have got it. Now, that is not our answer in this case. They didn't tell us to find the value of x. They said, how far is that boy from the fulcrum? Conclude your answer yourself now and say, therefore, the boy is 3 meters from the pivot or from the fulcrum. That is my first example. Example 2. Who's going to try it for us? There we go, example 2. So in this example 2, we need to note something. Try to interpret the question before attempting it. Members, try to understand it very well. What is the question saying? A boy weighing 60 kilogram force sits 2 meters away from the fulcrum, what we call the pivot of a seesaw. That is a boy. He's sitting 2 meters from the pivot, and this boy is 60 kilogram force. On the other side, or on the anti-clockwise side, who is there? A girl. What are they saying? A girl sits on the other side at a distance of 3 meters from the fulcrum in order to balance the seesaw. Find the weight of the girl. In the first example, we're calculating the distance of that boy. Now here we are calculating the weight of this girl, meaning they've given us distance of the girl, but no weight for the girl. But they have the weight of the boy and the distance of the boy. So what do we do? Remember that we can say let the weight of the girl be x, but to calculate the number very well, what do you need to do? To illustrate the diagram. Simplify your question which you are going to attempt in the diagram form. Then work is going to become very, very simple. Good. So we are seeing a diagram, right? That boy is 60 kilogram force. There is a distance of 2 meters. The girl is 3 meters. We don't know the weight of that girl. Okay? Don't know the weight of that girl. We say 2 things have to help us. Sketch the diagram. 2, apply the law of moments. Good. So the law, we have the load times load arm equals to effort times the effort arm times the effort arm. So we have 60 kilogram force times 2 meters equals to x, which is the weight. We are calling it kilogram force times 3 meters. Now members, we said we can ignore the units for now, but don't forget to conclude your answer with units. So ignore the units and say now 60 times 2 equals to x times what? 3. So we want to find the value of x, divide both sides by 3. So we have by 3, 1, by 3, 1. On this side we have by 3, 1, and also by 60 by 3. What do we get there? 60 by 3, that's 20. Now, we have x equals to 20 times 2. Side work. Who's calculating that number? Who's the calculating? Don't hurry. Go slow. Okay, so 20 times 2, what do we get? 40x. Who has seen a mistake on our answer? There are 2 mistakes. 40 equals to x. Who has seen the mistake? Number one mistake, they didn't tell us to find the value of x. They said the weight of the girl. We have been using this x as the unknown for that weight for that girl. Mistake number two, there's no units. So you have to conclude and say, therefore, the weight of the girl is 40 kilogram force. Thank you very much. Very nice candidates. I love you so much. Thank you. I have done 2 examples with you, and I know you have been following very well. Please, a reminder, in this, we need to apply the law of moments. Clockwise moments is always equal to anti-clockwise moment. Number 2, to attempt any diagram, you must first sketch it, then you attack it as a serious candidate of GGS. Now somebody's wondering, what is GGS? Global Junior School. Good. Now, okay. Can I give an activity for me? Okay. There we go. Always try to apply the law of moments. That's what I've been saying, telling you. For example, in number 1, they are saying, using a seesaw shown below, find length AB. Length from A to where there is what? To where there is B. Now, in that diagram, before you find that length from where there is A to where there is B, you first of all find the value of x. How? By applying the law of moments. Clockwise moments are always equal to anti-clockwise moment. Load times load arm always equal to effort times effort arm. Hey, by the way, I'm working for your number. Sorry, it's an activity. Work it out. So next time as we meet, we shall see who was that technical child who answered this technical question correctly. Look at number 2. If the weight of 120 grams at a distance 3 meters from the fulcrum is balanced by a weight of 30 grams on the other side, draw the diagram to represent the above information. This is also nice for a candidate. They want us now, in this case, represent that information in a diagram form. After representing it in diagram form, what do you do? They're telling us in part B, find how far the 30-gram weight is from the fulcrum, or what we call the pivot. Thank you, candidates. In the next lesson, we are going to deal still more. We are going to deal more about these moments. But you'll discover there is something unique which is going to be added. So pay attention, and you will not pick the other one if you have not got this one. Please, please, I beg. What do we do here? Apply the law of moments. Sketch the diagram. Good. Thank you very much. Stay safe. We love you so much. And please remember to use your mask wherever you're going. Just like me. I'm about to go home and I'm going to use this. And I'm going to put on myself. Have it. Stay safe.